I'm AM. We're watching AWS On Air right now. We're not watching, you are, but we're making it for you. From reInvent, with all the launches, all the partners, all the startups, all the game day, all the content. Steve, tell the people who you are.
Hey, I'm Steve Roberts, developer advocate for .NET and PowerShell. Happy to be here with AM again.
We've got a guest.
We have a special guest.
Ritz.
Yeah, thank you. Thanks for having me. This is really exciting. Yeah.
Right.
We're talking about a launch today, right?
We are. We are launching general availability today of AWS SimSpace Weaver. It's going to be the first simulation service specifically designed for sim developers for spatial simulations, for making large-scale spatial simulations and distributing that sim across multiple instances in the cloud.
Now, Ritz, we've done a lot with databases. We've done a lot with compute. We've done a lot with all types of different tech areas. Security, we just launched Security Lake today. Why has it been such a long time for spatial workloads?
The spatial simulations are a bit harder than just like a web server or another database, right? If you think about a simulation world, like literally a 3D world, like a 3D city, you have to think about, and you think about distributing that across multiple instances. Number one, you have to think, well, how do I split that world up, right? Like, how do I literally like take a three-dimensional map and move it onto different instances? Then you're going to have things that move in the simulation because you're simulating things. You're simulating people. You're simulating cars. You're simulating boats, whatever you want to simulate, right? And those will move around the simulation, and so you have to manage data and the data of those objects as they move. And you also have to keep the whole thing in time sync. Because you can imagine if you have one instance that's simulating and it's like 5 seconds ahead of another instance, those instances can't really interact, and that's not really what we're going for. We're going for real-time interaction across the entire sim. And so there's a lot of problems, and there's just a hardware problem, right? Here at AWS, we love to make it easy for customers to deploy safely in the cloud as well than deploy the infrastructure. So they spend less time worrying about infrastructure, more time coding sims, more time creating vast, expansive content for these 3D worlds.
So you mentioned problems as in hardware problems.
Yeah.
Right, the hardware requirements. What other problems do we typically encounter that's like taken so long to get this kind of simulation at scale?
Yeah, so the first is that you got to, well, actually, let me jump into some of the demos.
We're going to see it already.
I got videos.
You're our kind of guy, Ritz.
This is a lot easier to sort of visualize, and we like to kind of see what we've got. So let me just go full scale here.
Wait a minute.
That looks familiar.
Yeah, this looks rather familiar, right? This is Las Vegas, and this is a demo created here by our partners, uCrowds, and the data being provided by Cesium and Aerometrics. uCrowds is a startup based out of the Netherlands. They do AI for crowd behaviors, like how people would move in a city, for example, or you can think like a large sporting event, a concert. You want to like understand public safety associated with creating large events, or like this.
This is the actual simulation that I'm in right now.
Yeah, is what you're saying. Yeah, we're all living in the sim.
SimSpace Weaver is running reInvent that I am experiencing.
SimSpace Weaver, yeah.
SimSpace,
yes,
sorry.
Exactly.
I always thought reInvent was a simulation.
If we just sort of run this forward, we can kind of see this nice photogrammetry. We have a lot of the white sort of entities, the people walking around the city. So just to sort of some perspective, right?
There's you, Steve.
Yeah.
We scaled this to 1 million entities in Las Vegas. Now, that turns into that gridlock there because nobody can actually move. The entire population of Vegas is like 650,000.
I love that they've just overtaken the streets, too.
Well, that's the other thing, right? We had to close down the Vegas Strip to get people to actually be able to move around because there's just not enough sidewalk space to cram 1 million people in Vegas.
The thing is,
so you should not do that. You should not do that.
This is actually really accurate because if you go out onto the Strip, especially at night,
it looks like this.
You do congregate around the crossing points. This looks exactly how I remember it.
I just walked through that to get here.
This is, I believe, Caesars, right? If you want to take it, and then there's some. So you can understand like where there's going to be areas where people will congregate and where you might want to.
Make more space.
Yeah, more space and such. And there are actual scenarios which you would close down the Vegas Strip, for example, next year. F1 will race in Vegas, and they will close down the Vegas Strip. And so this is just the flat earth. But 1 million people is actually, like, perspective-wise, quite a lot. Like we're like, yeah, let's just put 1 million people on the screen, and then you're like, wow, that's a big number.
Yeah, I'm looking at this, and I'm thinking to myself, this is a colossal amount of data.
Yeah, it is. So this is updated. This particular simulation is updating at 10 hertz, which. Well, we can update at 10 hertz, we can update at 30 hertz, so 30 times a second, and you have a million entities updating 30 times per second, right? And
we're flying over all those people. That's a real nightmare I've had before, actually.
There's we'll get to this one here in a second too. There's we also have this one I wanted to show. This one was put together by our partners here. This is Maxar and Black Shark. So we did in New Orleans. Very similar here.
I love New Orleans.
In this particular one, it's a bit of a shorter video, but so this simulation is running on 10 AWS Amazon EC2 instances.
Just
so
10?
Just 10?
Well, it's
wow.
just 10.
We have more than
more.
that. We have more than that.
Yeah, well, they're pretty beefy instances. They're
Okay.
like we're taking up the whole box, right, in order to be able to do this. So, and as we look into the future, we'll continue to sort of increase the number that you can simulate with.
So I'm kind of curious. You mentioned earlier on partitioning across the compute hardware, right? So can you tell us, or what happens if like an object in one partition wants to interact with an object in another?
Yeah.
How does that work?
Right. So from the perspective of the developer, we are attempting to allow you to create one single seamless world, right? It's as if and from the perspective of the entities as well, it's as if the partitions don't actually exist to them. They just move across the partitions, whether that partition is on the same instance or it's across multiple servers. And like you saw that Maxar demo, I'm going to go live with the demo here. This is actually running
This is live?
This is live. This is running on this laptop. And they'll just like swing around here for a bit and zoom out because you can kind of see the whole city that we've.
Now, did you name them all?
I did not name them all.
I
would love to be able to like add like pets though. I could simulate my dog in here.
Pets?
Yeah, that'd be quite nice. So if we zoom in on this like nice little grassy area over here, the other thing is. It's a lot like a game in some aspects, right? These spatial simulations, they're meant to be interacted with, and so in this particular case, that is exactly what I will do. There's a nice little congregation of folks over here. I'm actually going to create. I'll create some more spawn points, and just let people. This is actually going to create more entities live in the middle of the sim as it's running. We'll zoom in here, and you can see they're spawning here, and I can create a. Bit of a. These are my destinations, and I'll link them together, and then the people should start walking in this particular direction. But again, we got to that idea of like if you throw a big concert, you throw an event, you might want to understand like where do I draw the boundaries, right? And where do I make sure that people can't go, for example? And so if I make a nice fence over here, you'll see that the people that were walking there now have to. They've changed direction. So they now have to walk around my fence. And so you can sort of like take the foundation of the geospatial data and use that as like the rigging of the real world, right? You can use that as the starting point and then add other synthetic elements to that. And now you're creating a simulation of what you want to have happen.
So it's a simulation of the control that you want.
Yeah, exactly.
Effective. I'm thinking like, when you go to a concert, and you park at the concert, and you see, one of these big arena things, right? And you like at the end of the night, and you see people leaving early because they want to get out of the parking garage quickly, right?
It's a massive traffic jam.
Which I never do that, and it ends up in a massive traffic jam, right? I can imagine one use for this is like, okay, we want to steer the cars these lanes to get out.
Wait, that means that you have left your house, right?
Yeah, I do.
So, okay, I don't understand what you're talking about because I'm in this simulation. I'm in one of those houses.
Sitting in the house.
I'm just not in this area at all.
It's probably best for everyone that you are.
Yeah, I agree. Ritz, so obviously people building simulations at this scale are utilizing common tools, Unity, Unreal, that type of thing.
Yeah.
When they're interacting with this service, how does that work?
Yeah, exactly. So let me explain that, and then I'll talk to the video. It's a great segue. So the other piece of this
Hear that? Great segue.
He's known for that. He's known for that, yeah.
Where's my other...
Doing my job, Steve.
Hold on.
This is one of the coolest demos I've seen, I have to say.
Oh, I love
all those little people walking around.
I promise I have this... OK, so here's the simulation stack as we see it. All right, so Weaver is at the very bottom. We are the scalable simulation infrastructure. Right? We are providing the hardware, the networking, the security, the data, right? Obviously, shared security model, but you got to Right. So the Unreal, the Unity, the custom C++, that's what we would call the simulation logic. That uCrowds simulation was a custom engine that was developed in C++, and actually Rust too.
Nice.
And then we're using Unreal as the visualization tool. Now the next one I'll show you is full end-to-end Unreal. So the Unreal applications, we're actually taking the Unreal application and we are distributing it across the 10 servers. And there's about 160 individual Unreal Engine applications that all run and work in concert. Wow. And then the simulation assets live above this. And so developers are responsible for the assets and the logic, and they plug in here at the bottom layer. So we are running the applications for them. And then what this ends up looking like, if you do this, if this is end-to-end Unreal here, the Epic had a city sample with Unreal Engine 5, and we took that city sample, had about 35,000 pedestrians and about 35,000 or 40,000 cars. We took that and scaled that up to 1 million pedestrians too, within this city. So this particular scenario done by our partner Duality Robotics, fantastic partner to work with here, and they're really we're looking at how do you minimize response times for EMS, for example, within a city. And in order to do that, we have to simulate the people in the city, the traffic in the city, and where there's going to be an ambulance that passes through. You have a traffic cop here that you can actually control. We have this demo running upstairs in the AWS Village. We'll have this on tomorrow and Thursday, too. And there's the ambulance that goes by. And so trying to optimize the route planning of multiple ambulances within the city. And I mean, this all you can see here, this all kind of lives within this living city of 1 million objects that all move around and can all interact and see each other at any time. So.
That traffic control point, I feel like could be the hot new Steam game, like traffic controller simulator.
Traffic control cop,
where you're directing traffic.
Yeah. Oh, so you get results at the end of the different simulated routes.
Right. So we had calculated various routes, and then we picked the one that minimized the time. And then in the demo upstairs, you can actually run the ambulance. You get to drive as the ambulance, but it's not Grand Theft Auto, so I'm setting clear expectations here.
Does it handle the case, where there's always an ambulance going down the street somewhere with the lights flashing, and there's a pedestrian steps out onto a crossing? It always happens.
It does. That's usually me.
Probably you, with your randomization, yes. Yeah.
That's pretty amazing. So, you're building your normal simulations. Maybe you've been struggling on how to actually scale it to these levels, right? And that's where Weaver comes in.
That's where Weaver comes in. Exactly. Nice. At some point, you go, okay, here's my simulation. I got 50,000 entities. All right, let me go back to AWS and get a bigger instance. I need a C5 12x or C6 now, and then okay, 200,000, and now I know I got to go bigger. So you just give me the biggest instance you got, AWS. And at some point, you're just like, one instance isn't enough, right? So now I have to scale out. And then you start thinking about the headache of the network replication, the hardware, the state synchronization, and that meme where you flip the table over. It goes through that, and then you think to yourself, well, this is fine fire kind of, or you can just use SimSpace Weaver and you're good to go.
Yeah, where do people go to get started with Weaver?
So it's live now on the console, so you can go to the AWS Management Console. It's under the compute category. We actually have a one-click sample simulation. It's a pathfinding simulation with a couple spheres, and they avoid blocks. You can view it through an Unreal client that you can download. Launch it in one click, but you can also launch it. We have 8 regions, right? Just don't all use IAD. You can have US East 1. Show the Oregon region and the Europe region and some love.
Spread the love around.
Yeah, always.
Yeah, this is seriously cool. I'm gonna have to check this console out.
Yeah, Ritz, this is an area of tech that I've always been just very interested in, but it's there's a lot of learning curve to it. Even I've got decade-plus programming, but it's different kind of programming when it comes to simulation. But very cool to see the infrastructure side of that.
Yeah.
So you can focus on just building your simulation. Taken away, dealt with by Weaver. I love it. Now, we've got to move on to our next segment, unfortunately.
Yeah. No, thanks for having me. This has been fantastic.
Thanks for coming along.
Thank you so much.
Thank you.
We will be right back with more from AWS On Air. Stick around.